Alright guys, today is August 6th. We went ahead and we took a look at different operations with complex numbers, but we skipped dividing. So today we're going to talk about dividing complex numbers. You also see this called sometimes rationalizing complex denominators. Alright, we're just going to call it dividing complex numbers. Alright, so here, the first thing you need to know in order to divide a complex number is what a complex conjugate is, okay? So a complex conjugate, all right? So here, when we have a complex number, right, we've got a plus bi, all right? If we want to know its conjugate, what we're going to do is we're going to make it a minus bi, right? So let's talk about what changed here. You can see a stays the same, right? So the real part, a, stays the same. Okay. The imaginary part, we've got plus bi became minus bi, right? So the imaginary part which is bi, right? We use the opposite, right? Because remember, this doesn't necessarily mean negative or minus. It means the opposite of bi. So here, whatever the sign is, we're going to change it over there. All right. Now, if we're taking a look here, just like some examples, right? Let's say we've got 7 minus 8i. Right. Well, what is the complex conjugate going to be? Well, the complex conjugate, 7 minus 8i, is going to become 7 stays the same, and then the opposite of minus 8i is plus 8i. So that is the complex conjugate. Okay? We take a look at one like negative 2 plus 3i. Complex conjugate is going to be, again, the negative 2 stays the same, and then this is plus 3i. The opposite of plus 3i is minus 3i. So that's how we get the complex conjugates. Okay? We're going to use this to help us rationalize these denominators, right? Because there's this rule when you're simplifying a fraction or a complex expression, right? You can't have I in the denominator. It's against the rules. It's actually a bigger rule that you can't have a radical in the denominator. And since I is the square root of negative 1, it is a radical, okay? So we can handle this a couple different ways, right? So just real easy case, right? If you have something like 3 over 2i, right? Well, here I can't have I in the bottom. Good news is, if I multiply any imaginary number by any imaginary number, it becomes real. So in a case like this, I simply have to multiply by I on the bottom, and I'll multiply by I up top. Now when I do this, I end up with 3i over 2i squared. And we know that when we see I squared, we cross it out and change the sign. So we end up with negative 3i over 2. Okay? So again, very, very easy. That's kind of like this trivial case. All right? But if we take a look at a slightly more challenging problem, right? Maybe one where we've got something like 1 over, let's go 10 over 2 minus I. Okay? So first thing here, right? If I just multiply top and bottom by I, it's not going to work, right? So, because watch what happens, right? If we multiply the bottom by I, we multiply the top by I, right? Great, I get 10i up top, but on the bottom, I distribute this I, and I get 2i minus negative 1, which becomes plus 1. But look, I still have I in the denominator, and I'm still not allowed to, right? So this process doesn't work here, right? But that's why we went ahead and we developed this idea of a complex conjugate. So what we're going to do is we're going to take a look at, well, what happens if I multiply by the complex conjugate? So here, we've got 10 over 2 minus I. So what I'm going to do is I'm going to multiply top and bottom by the conjugate of the denominator. So 2 minus I, the conjugate is going to be 2 plus I. Whatever I do to the bottom, I have to do to the top, right? Because now what I'm doing is I'm really just multiplying by 1. 2 plus I over 2 plus I is 1. If I multiply by 1, I don't change the number. Now up top it's going to be easy. I'm just going to distribute that 10. 10 times 2 is 20. 10 times I is 10I. Now on the bottom here, I'm going to use a little shortcut, right? Because look at this conjugate, right? This is like A plus B and A minus B. It's kind of like a difference of squares. So what I do here is I basically square the first one. 2 times 2 is 4. Minus, and then the second one. I times I is I squared. Now we know that I squared is negative 1. So I cross this out and make it plus 1. I end up with 20 plus 10I over 5. Now here that's not enough. We got to go ahead and simplify this, right? Now don't mess up here, right? A lot of students back at the beginning would say, oh, 10 minus 2, I can make that 5. No, you can't, right? All three numbers have to be divisible by the same thing. Here 20, 10, and 5 are all divisible by the same number, which is 5. So 20 divided by 5 is 4. 10 divided by 5 is 2. So I get 4 plus 2i. So here, the original problem, 10 divided by 2 minus I is equal to 4 plus 2i. All right. Let's go ahead and take a look at maybe a couple more examples where we're using the conjugate. So here, number 2, we're going to take a look at 80 over 2 minus 6i. All right. Now again, we just talked about this, right? What do I notice about 80, 2, and 6? Well, they're all divisible by 2, so that's the first thing I'm going to do is I'm going to go ahead and divide them all by 2. So I get 40 over 1 minus 3i. All right. Now you can see I have a complex number in the denominator, so I'm going to multiply top and bottom by the conjugate. So I'm going to use 1 plus 3i on the bottom, 1 plus 3i. All right. Up top is easy. 40 times 1 is 40. 40 times 3 is 120. Right. On the bottom here, I've got 1 times 1 is 1, minus, and I've got 3 times 3 is 9i squared. Again, I cross out the I squared, and I change the sign. So I end up with 40 plus 120 I over 10, which simplifies to 4 plus 12i. All right. So again, just keep the numbers small, keep them simple. All right. Next problem we're going to take a look at, we'll call this one example 3. So we've got here 4 minus 3i. So now we have a complex numerator and a complex denominator, negative 1 plus 2i, right? So again, there's nothing to simplify here because 4, 3, 1, and 2 are not all divisible by any numbers except 1. So I'm just going to go ahead and multiply by the conjugate of the denominator. Conjugate of the denominator is negative 1 minus 2i. So I multiply the top by negative 1 minus 2i, right? And then here on the bottom, I can kind of use that shortcut we've been talking about. Negative 1 squared is 1. And then minus 2 times 2 is 4i. So I get 4i squared. Cross out the I squared, change the sign. Now I haven't been doing this on the bottom, but I could box these up. I could FOIL these. That's what I'm going to have to do up here. I'm going to have to box these up or FOIL them. Okay? I'm going to go ahead and FOIL, so I'm going to distribute this 4. 4 times negative 1 is negative 4. 4 times negative 2i is minus 8i. Negative 3i times negative 1 is plus 3i. And then negative 3i times negative 2i is positive 6i squared, which I cross out and change the sign. All right. So now we're going to go ahead, we're going to combine like terms up top. Negative 4 plus negative 6 is negative 10. Negative 8 plus 3 is negative 5. All over 1 plus 4, which is 5. Again, we can reduce this, so we end up with negative 2 minus I. All right, so again, you can box up the top, or you can distribute the way I did, first, outer, inner, last. Either one's going to be fine. All right. Let's take a look at one more where we have to do that whole first, outer, inner, last thing. Right? This will be example number 4. Okay. So we have here is 4 minus 4i over 1 plus 3i. So again, I try to reduce 2 4s, a 1, and a 3. Nothing to reduce. All right. So I'm going to multiply by the conjugate. Conjugate of 1 plus 3i is 1 minus 3i. Whatever I multiply the bottom by, multiply the top by. On the bottom, we use our shortcut. 1 times 1 is 1. 3 times 3 is 9i squared. 1 plus 9. Up top, 4 times 1 is 4. 4 times negative 3i is negative 12i. Negative 4i times 1 is negative 4i. And then negative 4i times negative 3i is positive 12i squared. Change the sign. Combine like terms. 4 plus negative 12 is negative 8. Negative 12i minus 4i is negative 16i. And then here, 1 plus 9 is 10. Now here, so far they've all reduced very nicely. This one still reduces. All right, what's the number that goes into 8, 16, and 10? Well, I actually like to break them up here, right? Because I'm still looking for a plus bi. So if it helps you, I'm going to write negative 8 tenths minus 16i over 10. And then I'll reduce, and I end up with negative 4/5 minus 8i over 5. The reason I like to break it up is the directions will usually say something like write your answer as a plus bi. And so here, if we write our answer as a plus bi, I can see here that a is negative 4/5. I can see that b is negative 8/5. So that's why I like to write my answer that way. If you leave it together, that's going to be fine too, either way. All right. So tonight's homework, we've got 5 problems where I'm going to ask you to go ahead and rationalize the denominator. All right. I'll be honest, in my opinion, the tricky one here is number 2, if you weren't paying attention during the notes. It's the trivial case. So here, just remember, this one's easy. Just look back at your notes, what we did for that trivial case. All right. But the rest, again, should be pretty accessible. All right. Make sure you show all your work. You're going to submit that to Canvas, and we will make sure that we are ready for a quiz on Friday on complex numbers. Email me if you have questions.